Is artificial intelligence blowing your mind? Are you confused by all the terms, all the acronyms, and the endless jargon? Well, you're in the right place. Welcome to the Future of Us. I'm Ant Morse. I'm a futurist, an author, and a business transformation specialist. I explore all things technology and tech related, and hopefully I make the complex simple. So in this session, we're going to look at machine learning and deep learning. Now, we know that artificial intelligence is the process of a machine mimicking human intelligence. And machine learning and deep learning are just a number of many subsets of artificial intelligence. In effect, they're a system, a process, a technique. And to help this example further, if we were to think about artificial intelligence as perhaps the field of travel, a car might be machine learning and an aeroplane might be deep learning. Both technically do the same job in taking you from A to B, but they both work with very different technologies and both work in very different ways. So let's start with machine learning. Now, machine learning has been around for many years. It's very commonly used in enterprise and organisations where they use it to sift through large data sets to find patterns, spot trends, or to take action and to automate manual processes. But if we wanted to use machine learning in another example, let's say we are looking to sift through millions of images of cats, dogs and birds, what we would do is we'd initially set out to label some data. This is to help guide the AI model along, such as we might put in that cats have pointed ears, small noses, whiskers, dogs have floppy ears, big nose, etc, etc. We'd then add those labels to a couple of pictures of each as a guide. We would then show the AI model the images and we'd ask it to work out the answers. Does it have pointed ears? It could be a cat. Does it have a small nose? Yep, looking like a cat. Or yes, it's got whiskers, so it's highly likely it's a cat. Now, this initial labelling process is a technique known as supervised learning. Now, another learning process in machine learning is known as unsupervised learning, where we let the AI system try and work out the answer itself. And depending on the use cases here, sometimes it more than likely will be way out on its first attempts. But this is where we come into play. With a bit of training from us as humans, we're still relevant, coupled with some artificial intelligence pattern recognition techniques, the system can then quickly resort the data with our training and come up with the right answers. And depending on the task in hand, it usually dictates whether an organisation would use unsupervised or supervised learning. Often consider simple processes would be supervised and more complex would be unsupervised. Now, we do put a lot of faith in AI as organisations, which, as impressive as it can also often get the answers wrong, which makes that point I just referenced then about training and our input incredibly important. And for me, this is one of the examples of where robots will impact our jobs, but actually we'll probably more see an evolution of our role and AI training become part of what we do rather than it just disintermediate us from work. And also as well, to be super clear, we don't need to be computer scientists to be AI trainers. As your organisation starts to deploy more and more AI solutions, it's highly likely that this will just be a natural and gradual progression of your current role. A real life example of where machine learning is used is in things like spam filters. The machine looks for words in emails such as win, free, offer, savings, and then pushes these to your spam folder. Now let's move us on to deep learning, which is a much bigger topic and field overall, but put simply for our explanation here, this is where machines dig a little deeper. So usually machine learning is considered as a limited, usually up to 3 checks of computation, but deep learning is where, as the title suggests, it goes deeper. So in this case, if it was looking at pictures of cats, it would ask the first 3 questions, but then it would say look for a particular shape of eye or look for sharp claws, just as an example. And when it gets to these types of technologies, it then brings in new techniques. The computation is deeper, so it brings new techniques to be more efficient. And this is where you'll hear a term referred to as neural networks. So in machine learning, it works out very, very systematically. Has it got pointed ears? Yes, it might be a cat, but it pauses at that point, ready to do the next one, then the next, then the next, then the next. And when it's got all the answers, it then collates the summary. With deep learning and neural networks, it works far more efficiently. It works exactly like the human brain does, in that it's immediately linked to all of the other answers instantly. So the neurons in our brain, when we see a cat, we see the ears, we see the fur, we see the claws, we see the whiskers, and we immediately know it's a cat. Deep learning works in a similar way. And it's this increased efficiency of computation that allows us to use artificial intelligence and particularly deep learning in far more advanced use cases, whether it's unlocking your phone by looking at it using Face ID, or whether it's object recognition in a self-driving car, looking at the road ahead and seeing obstacles or road signs and taking the relevant action. Well, that's it for this video. Until next time, stay interested, stay curious, but most of all, stay relevant in the future of us. Glasses are still wonky. I give up.